Hi there, I'm Han. This is just another video of me solving random numerical problems. So we have minimum following path sum, have an n by n matrix, all right? And we need to find the minimum sum of the following path through the matrix, right? A following path means start any elements on the first row, any element on the first row, and go to the next row, right? Either directly below or diagonally left or right. So if I'm starting at one, I can go here, here, or here, right? It has to get to the end, of course, right? First row to last row. You can start any element on the first row, um, and stop at any element on the last row. So we can use a DP variation for this, right? Let's say I have 2 and 3. I don't care about or let's say, okay, just make a copy, right? Instead of going up, sorry, instead of going down, right? We can go back up, right? We can start from the last row, right? Because we are already at the last row, right? So we must pay the price, right? To be at the last row, at the last cell in the row, right? So there's nothing we can do about this, right? So this will only be 7, 8, 9, right? Okay. Um, and we can go back up, right? So we can start from the second to last row, right? Second to last row. So we can look at 4, right? We're gonna check 4 plus 8, 4 plus 9, right? We don't have a right neighbor, right? We don't have a diagonally right neighbor, right? So we don't care about that, right? So this is gonna be 12 and 13, right? And 12 is smaller, right? So we pick 12, put 12 here, right? We just have to take the minimum, right? Using our greedy approach, right? So 5 we have 3 neighbors, right? So we have 12, 13, and 14, right? So of course we pick 12. We pick 12 like this. So 6 we have 3 neighbors, right? Sorry, 2 neighbors, 6, 7, and 6, 8. So 13 and 14, right? So we pick 13. So this would be 13, right? And we are done, right? We will moving to the next row. So 3, we have 2 neighbor, 1 and 12, so 4 and 15. Well, of course, we're gonna take 4, right? Because it is smaller, we want a minimum path, minimum following path. Maybe 4, right? 1 have 3 neighbors, right? 13, 1, and 12. 1 is the smallest, of course. There's gonna be 2. 2 have 2 neighbors, right? 13 and 1. 1 is smaller, so this becomes 3, right? Wait, is that right? The answer is 13, right? Did I do something wrong here? Oh, yes. Yeah. 3 has 2 neighbors, right? Uh, what is the one in the middle? 5, right? Oh, this would be 12. It's not 1. I accidentally deleted number 2 here. My bad. So, 5 have 3 neighbors, right? And then 5 and 7 is the smallest here, right? Which is 12. I accidentally deleted the 12 here. That's why it's so weird. The answer is weird. Okay. So 3 have 2 neighbors, the same, so we don't care. There will be 15, right? 1 plus 12 is 13, because 12 is the smallest among three neighbors, right? 2 gonna be 14, right? Because 12 is smaller than 13, right? So now we are done. So because the cell can be stored at any cell on the first row, so we just have to iterate through the first row and take the minimum number, which is 13 here, and that is our answer. All right, let's put this up. So we gonna have our n as matrix of line, right? It is an n by n matrix. Okay, and at the end we will return the minimum number, right? The minimum sum on the first row, which is method mean of matrix 0, right? Matrix 0 is 0 gonna be the first row here, right? And we just take the minimum sum. Okay, so row equal to 0 to n minus 2. So we're gonna skip the last row, right? Because the sum is the same as the last row, right? If we are at the last row, then we need a 7 and 8 or a 9, right? We can look at 0, row minus minus. Column equal to n minus 1. Column equal to 0, and then column minus 1, right? So we need to look at three neighbors, right? The bottom mid, which is the matrix of row plus 1, column, right? Because we are starting from the second to last row, we will always have the cell of row plus 1, right? We have bottom left, right? So if the column is 0, right, which means we don't have the diagonal left neighbor, right? So we're just gonna return infinity. And then the bottom right, we have a similar problem, right? So if the column is the last column, which means we don't have the diagonal right neighbor, right? So we just return infinity here. And then we have to update the sum, right, on the current cell, right? Which is the current sum plus equal the current cell plus equal the minimum of the three neighbors, right? Which is the bottom left, the bottom mid, right, and the bottom right, right? I set it into infinity here so that if they don't have the left neighbor or the right neighbors, right, it's just gonna get eliminated uh, through the method mean because it is infinity, right? And nothing is bigger than infinity. And yeah, that's pretty much it. Thank you for watching.